Hey everyone, and welcome. Today we are diving into something really cool, and maybe a little weird. How does a computer solve a puzzle when it has absolutely no strategy, no intuition, no intelligence, nothing? It's kind of like being dropped into a maze with a blindfold on and being told, good luck. So let's get into it.
So yeah, this is the big question, right? You and I, we look at a puzzle, and, we probably try to plan a few moves ahead. But a computer using a blind search, it doesn't do any of that. It just follows a very simple, very rigid set of instructions and basically stumbles its way to the solution. But how on earth does that actually work?
To really see this in action, we're going to use a total classic from the world of AI, the 8 puzzle. It looks simple, but trust me, it can get surprisingly complicated to solve. And that makes it the perfect training ground for these kinds of search algorithms.
Okay, so every puzzle has a beginning and an end. Pretty simple. On the left, you see our starting point, the jumbled up grid we call the start state. And on the right, that's our destination, the perfectly ordered goal state. The whole game is just figuring out how to get from point A to point B.
And the rules? They're about as simple as it gets. The only thing you can do is slide a tile into the empty space right next to it. So you can think of it as the empty square moving up, down, left, or right. That's it. Those are the only moves you're allowed to make.
So how does the machine tackle this? Well, not with cleverness, that's for sure. It uses pure brute force. It's what we call an uninformed or blind search. It literally has no idea if a move is getting it closer to the goal or further away. All it knows is that it has to check every single possibility.
The specific method it's going to use is called breadth-first search, or BFS for short. The best way to think about it is like ripples in a pond. The search starts in the middle, and it explores everything in that first ripple before it even thinks about moving to the second ripple. It goes level by level by level, making absolutely sure it doesn't miss a thing.
And this really shows you the AI's entire game plan. It's just a simple repeating loop. First, it looks at where it is and figures out every single possible move it can make. Then, it checks, is any of those new boards the final goal? If the answer is no, well, it takes all of those new boards and just repeats the whole process all over again.
All right, enough with the theory. Let's actually watch this blind search do its thing. We're going to follow the algorithm step by step as it just methodically plows through the possibilities level by level.
So the search begins at ground zero, or what the algorithm calls depth zero. This is just our starting puzzle. The AI asks itself exactly one question. Is this the goal? Obviously the answer is no, so it knows it has to go deeper. Okay, now we're one level down, at depth 1. From that starting puzzle, the AI calculates every legal move. So let's say it can move the blank tile 3 ways. It creates those 3 new puzzles and checks each one. Is this the goal? Nope. How about this one? Still no. All right, time to expand the search again.
And now, this is where things start to explode outward. The AI takes all 3 of those puzzles from depth 1 and generates all of their possible next moves. Suddenly, what was 3 branches becomes, 7 or 8 new possibilities. We're now at depth 2. And again, it checks every single one of them. Still no goal.
So the AI takes all those states from depth 2 and expands them one more time, creating a huge new wave of possibilities at depth 3. It starts checking them one by one. And then, bingo, it finds a match. This puzzle state is exactly the goal state. And just like that, the search is over. It stops right there and reports back that it's done.
So it worked. The blind, methodical process actually found the solution. But, and this is a really big but, at what cost? Just because a method works doesn't mean it's, any good.
This brings us to a concept called time complexity. Now, this formula, O of B to the D, might look a little intimidating, but the idea is actually pretty simple. B is just the branching factor, basically the average number of moves you can make from any spot. And D is the depth, how many moves away the solution was. The big, scary problem here is that this is an exponential relationship. The numbers get big fast. So what does that exponential growth actually look like? Well, in the absolute worst-case scenario for this puzzle, the number of puzzle states the AI might have to check it's just staggering. It's 3.5 times billion. That's the real price of being blind. You might have to check billions of wrong answers just to find the single right one.
So where does a terrifying number like that even come from? It comes right from that formula, O of B to the D. For the 8 puzzle, the branching factor B averages out to about 3. The longest possible solution, the depth, D,
can be around 20 moves, and 3 to the power of 20 is, yep, almost 3.5 billion.
And if you're wondering where that branching factor of 3 comes from, it's just an average. As you can see here, if the empty tile is in a corner, you've only got 2 possible moves. If it's on an edge, you've got 3 moves, and if it's right in the sweet spot in the center, you've got 4 moves. You average all that out, and you get about 2.6, which, for our math, we just round up to 3.
Okay, let's bring this all home. What we have here is a method that absolutely works, but it has this massive, potentially crippling downside. This is the fundamental trade-off you make when you use a blind, uninformed search.
So let's just lay out the pros and cons. On the plus side, this method is guaranteed to find a solution if one exists. And because it explores level by level, the first solution it finds will always be the best one, the shortest path. But the cons? Wow. It can take an absolutely insane amount of time and memory. It might have to explore billions of totally useless paths just to get there.
You know, a line from our source material just sums this up perfectly. It says the agent will explore all the states. One by one, it will go in each move and each depth. It doesn't think, it doesn't strategize. It's a guarantee that comes from pure, exhaustive, stubborn repetition.
Which leaves us with this one final, really important question. We've seen the power of this blind search, but we've also seen its immense weakness. It works, but man, it is brutally inefficient. So, what's next? How can we give the machine a sense of direction? How can we teach it to search smarter, not just harder? Well, that's the key to the next level of AI, and that's a story for another time.